Okay. So, hello everyone. It's Rishi here. Today we'll look into Docker. And just to before we start into Docker, I'm Rishi here. Um, we are from Capable. We have a lot of sessions about different data science streams and so on. So today's topic will be mainly towards a Docker and how it works, how a data scientist will be using it, and how it is being generally used most of the times in the industry as well as an individual data scientist. Okay, so today when we say Docker, you would be thinking of something like a symbolic whale with some blocks over it, right? So in terms of to understand what Docker is, we'll have an introduction. In this, what we will see is that Docker is mainly for containerization. Now you will be thinking, what is a containerization? So think as you will pack everything in one place and then ship it to a different person or to a team member or to any other person. So that's what Docker generally does in simplest terms. Okay, and it is a user friendly. That's one of the key importance what Docker has. Okay, so we will see what is Docker. We'll see Docker versus virtual machines. We'll also see advantages of Docker and components of Docker. And also in the last, we'll show you a case study so that you can understand how Docker generally works. Okay, cool. So what is Docker? In simplest terms, like I said, Docker is an OS virtualized software platform which allows IT organizations to create, deploy, and run applications in Docker containers. Right. Now, this is just an explanation of what generally Docker is for all those students who really don't know what Docker is. If someone asks you, or if someone just asks you, like, have you worked on Docker? Have you heard about Docker? You can say that yes, Docker is an operating system virtualized software platform that allows different organizations to quickly create, deploy, and run applications. Okay. So you would be thinking, okay, virtual machines have been there in the industry for long times. Why is it Docker so much used in today's generation as well as today's industry standard? So yes, virtual machines are great. They work really good, but they have something in problem is that the emulation of the entire operating system is there. So if I say virtual machine, from the word, if you understand, it is like a virtual machine. It's not the hardware, but it is a virtual machine having uh, the OS level virtualization. That means you will find everything, even the root directories, even everything else will be present in a small machine. Whereas Docker is just a containerization technology. What it does is, in simple terms, it will have some rules and it will have different layers, and in that layers you will have some image and contain and a container running that image, right? So you can think of it in that way. Okay, right. So we saw difference of Docker versus uh, the virtual machines. Now there are some more advantages also. The first thing is scalability, and you can easily scale that code which you have written as well as a container to any other different level. So that's the plus point of Docker. Also, it is very portable. When I say portable, I can share a Docker file with you guys, and you just need to run one command, and it will work in your machine. So the one of the basic advantage of a Docker is that sometimes what happens is some code which I have run on my machine will not run on your machine, right? So there is a problem of reproducibility. But when you when you pack when you containerize everything what you have made and give it to an other person or a team member or let's say even the production level, you can easily these are few of the advantages of Docker. Okay, now we have seen till now advantages, we have seen how it is different from virtual machines and what is Docker. So now just giving an idea are some things like components, right? So some of the components in Docker are Docker client and server, Docker registry, Docker image, and Docker container, right? I don't want you to get too much focused on each component, but just imagine that you have an image. From the image you create a container. Okay, now let's just look into image and container to make you bit comfortable about what Docker image is and how it's different from a container. So a Docker image is a lightweight, standalone, and executable package that contains everything need to run a piece of software. So for example, let's say that a Docker image is nothing but like is made from a file called as Docker file, right? I'll show you all these things, how it looks. So Docker file is nothing but a set of instructions, right? When I say set of instruction, it's as simple as which Python version you want, which operating system you want, what steps have to be made. So that image which gets built up using the Docker file is nothing but a standalone and uh, executable package. That means you can use that to execute uh, and in and you can even connect with the image itself. Okay, so what is a Docker container? A Docker container is a lightweight isolated runtime instance. What it is, that it is a runtime which is very lightweight, and it is just directly running your Docker image, right? Now you can have multiple containers running, as well as from a single image you can have multiple containers which can be done, which can be made, right? So the plus point of this Docker container is that because it is standalone, it doesn't have any other dependencies. It has all the other dependencies present inside it. You can run it, you can test it, you can even deploy it in the production. And because it's again connected uh, to a base image, or let's say Docker image, you can easily deploy it in the production and let different containers connect with one another to get your uh, whole production level deployment. Okay, cool. Let me just share you another screen where I will talk about a small project where you can see how this works. Okay, give me a minute. Okay, so this is my VS Code. This is a code editor like I use. So in this, I have this file. Just try to understand this, that I have this file, which is my some machine learning lecture which I want to perform. And in that machine learning lecture, what's happening is the data is nothing but something like this, right? I have frog, I have truck, I have different classes, and each class and each image is linked with that particular label. Okay, so in simple terms, I create a model which will, if given image, it will say whether it's word, whether it's struct. So it just classifies it depending on the input I give. Okay, so what I do now is I have this Docker file. Now just think of Docker file as some, like I said, some set of rules. So for example, I have Python 3.10.8, the maintainer name, and some packages which I want in my requirements.txt, and then the run command, work directory. So in simple terms, it is just telling that uh, when you create this Docker image using this Docker file, these are some of the sets, or these are some of the rules which you will be using it. Okay, so what happens is once I run this, if you see, let me share that screen. Yeah, so once I build this image, I also share it on a hub where it's accessible to everyone, right? I'll show you that also. But let's just see when I show you the output. Yeah. So if you see at the moment, if I just run this, it is showing me a 47% of accuracy. Okay. For now, just see that when I run the code on my machine, I still get 47% accuracy. Okay. Now, when I make this and I want to share it with every other person, what I'll do is I will push it to a Docker hub. Now, this is like my repository Rishi1304 with a CFAR classifier. So if you see, you can just do a pull and you can get the commands. So 1.4 is the latest version which I have made. You can straight away go and uh, just download it here, and you will get the whole code with its dependencies, like all the packages, everything all compressed together in your um, local machine. So what did Docker help us in till now? Docker helped us in not only uh, developing a code from base, but also to share it across different people without having a problem of dependencies, as well as any other requirement, like you have to install TensorFlow, you have to install different packages. But in short, what it gave you everything in one shot. So you can have a Docker image as well as a Docker container, just to run your own scripts, right? So what this is useful, this is very useful when you are working on a bigger project, or let's say a smaller project which have different components. Now each component you can have, let's say that I built up a machine learning model. Now this model could be used in different scenarios depending on the problem statement. So this is why, in simple terms, Docker is very useful and is used in the industry. And yes, we do share knowledge about this at Capable. Yeah, that's pretty much about Docker. Is there any questions? Please feel free to reach out, and I'll hand over to Umang. I can share with GitHub, but the problem is, let's say that it runs on my machine, right? The code runs very fine. The model gives a very good accuracy, or a particular score gives on my machine, or using some Python packages and the other versions of of a particular code, you will have a problem when you run it on different machines, right? So that's why when I say in production, you never know that how your uh, production environment is gonna be generally when there are different packages also. So yes, you can use GitHub, but the major stable way of sharing is you can use Docker file. So that way it gives a better results.